Hey, good afternoon, everybody. I hope everybody's had a chance to grab some lunch. Just a quick quick check here. This is ENT306, SQL Server on AWS, run with the best. So just in case you find yourself in the wrong room, just want to make sure you know what you're in for.
Okay, great. Thanks, Andy. I'm Bill Jacoby, Principal Solutions Architect at AWS, and welcome to today's session. You'll be hearing from both myself and Andy about how to run SQL Server with best practices for deployment, operations, high availability, management, disaster recovery across the AWS native and managed SQL Server database options. So we hear lots of questions from customers. We hear customers asking at a very basic level, can I run SQL Server on AWS? Does it run reasonably well? The answer is absolutely it does. We also get all the other questions that you see on the slide here, and we'll cover all of these questions as we go through the presentation. So our agenda today is why and how should I run SQL Server on AWS? We'll talk a little bit about the why, and the majority of our talk will really be focused on the how. We're also going to talk about how to migrate and operate SQL Server at scale. So we'll talk a bit about the automation technologies that are available, the automation that you get through our managed SQL Server platform, the automation technologies available to you using SQL Server natively on AWS, Elastic Compute Cloud. We'll talk about high availability and disaster recovery, and we'll also talk at the end about how, if you want to run SQL Server applications, you can run SQL Server applications against an open source database using T-SQL and using your standard SQL Server calls and drivers. So Andy will talk about that last bit. Okay, so let me just start off with deployment and modernization options. And we really have two main approaches. Our first approach is what we call the self-hosted approach. And the self-hosted approach is running SQL Server on Amazon Elastic Compute Cloud. Amazon EC2 is our virtual machine service, which has a range of sizes from 1 vCPU all the way up to 448 vCPU, and memory from under 1 gigabyte of RAM to well over 24 terabytes of RAM. So we have a very large spectrum of capabilities on our EC2 platform, and when you run SQL Server on EC2, you have complete control of your database servers. You have complete control over compute, storage, networking. You have complete control over things like replication, connecting to file systems, creating disaster recovery plans. You own the whole configuration just as you would on premises. Now, AWS offers a range of CPU, memory, storage, networking, local disk to allow you to optimize your SQL Server on AWS. And all of those configuration options I just mentioned give you the ability to look at any particular SQL Server workload and optimize it for the applications that are connecting. So we do support all features and, by the way, all versions of SQL Server on EC2. So when I say all features, all the high availability features, all of the database scripting features, somewhat esoteric features like database mail, resource governor. If there's a feature in SQL Server that operates on premises or operates out of the box, it'll also operate on Amazon EC2. We support high availability through our storage services. So SQL Server, the self-hosted approach on EC2 supports always-on availability groups, Windows Server failover clusters, cluster failover instances, and any other SQL HA feature that you want to use. SQL Server on EC2 also supports BYOL licensing. So if you own SQL Server licensing, which you've purchased through an enterprise agreement or through a reseller, you can bring those existing licenses to AWS, and we will not charge you for an additional license. We'll charge you for the underlying infrastructure that you choose, the compute, storage, and networking, and other AWS services that you surround your database with, but we won't charge you for a SQL Server license if you bring your own. Now, lastly, we do have customers who say, well, Amazon, you've been running SQL Server on AWS for 10 years. You have some best practices. And so if you want to, although you can run on SQL Server EC2 as a self-hosted platform, you can hand your databases to Amazon Managed Services our AMS practice, in which case we will operate SQL Server on your behalf. So we'll employ all the best practices that we're aware of and that we've written about quite a bit on our website, and we'll operate SQL Server for you, including setting up high availability, setting up optimizing performance, setting up monitoring and logging, setting up alerting, and all those things. So AMS is an optional service if you want to go the self-hosted route, but have AWS do the operations. Now, alternative to the self-hosted option, self-hosted approach, we also have a managed approach. And our managed approach for running SQL Server is based on running Amazon RDS, Amazon Relational Database Service for SQL Server. And in this case, we as a service provider will manage all the operational requirements of the underlying Windows servers, the underlying SQL Server, the underlying storage, and all of your database backups and patches. So we'll patch the underlying Windows servers. We'll also patch the underlying SQL servers. And if you tell us to, we'll also upgrade your SQL servers when new minor versions come out. So we'll completely manage the operations and the patching. Once you've set up and once you've configured a database to run on AWS RDS, then you can connect to your database using SSMS or any other SQL Server tool that will connect over port 1433 and use SQL Server drivers. So there's nothing unique or proprietary. When you run SQL Server, when you have us operate SQL Server through RDS, you can use any tool that you would use on premises to connect to SQL Server. RDS for SQL Server offers a range of compute and storage options, which we'll get into in just a few minutes. So you have that same ability to choose how much CPU do I want, how much memory do I want, how much networking performance do I want, and you can dial those resources in to give you an optimal price performance configuration for your database. RDS also provides managed high availability. So you can click a button and you can say, I'd like my database to be highly available, meaning we will manage it across Amazon availability zones, and depending on the edition that you chose, we will use always-on availability groups, or we'll use SQL mirroring. And so you basically just click a button and say, I'd like to have Amazon RDS manage my database with high availability. There's nothing, you don't have to set up failover clusters on your own. You don't have to set up always-on availability groups. You just say, set up high availability, and we provide it as a service. Now, RDS does come in two flavors, a fully managed flavor and a custom managed flavor. So the fully managed flavor is one where we manage and run everything on your behalf. We manage and operate SQL Server. You choose compute, storage, networking, and then we run the database. You click the button, you want high availability, we provide it. And 100% of the operations are provided by us, including patching, backup, HA. Alternatively, we have a flavor of RDS SQL Server called RDS Custom. And RDS Custom is a case where we allow you to configure the SQL Server database while we still provide scripting and operational capabilities to run the database on your behalf. So we'll still provide operational capabilities, but we allow you to go in and provide custom configuration, which integrates with our service. So just to sort of recap, SQL Server on Amazon EC2 is the self-managed experience. You have full control. You have all database features. You have the ability to control patching. You have the responsibility to perform patching, high availability, and you can run third-party or your own apps on the database host. At the complete other end of the spectrum, RDS for SQL Server is a managed experience. We don't give you SQL SA. There's no sysadmin. There's no access to the operating system, but it is an optimized architecture for SQL Server. And we on the Amazon side provide automated provisioning, automated monitoring, automated backup, restore, and point-in-time recovery for any particular database. We provide the patching, we provide high availability, we provide multi-AZ, HA, but you cannot put third-party applications on the host when you're using Amazon RDS. So that's where we have this sort of Goldilocks option in the middle, which we call RDS Custom, where it's a managed experience, a shared responsibility, where you can configure SQL Server, you can configure features, you can turn on features like the resource governor, you can use stored procedures like the .NET CLR to run custom .NET stored procedures. So you have full control over the database, and we still will maintain operations, meaning patching, backup, those kinds of features. So we will still provide automated provisioning, monitoring, backup, restore, point-in-time recovery. We'll do automated patching. You can do additional patching. You can do additional backups. You provide high availability with RDS Custom versus our providing it directly as Amazon. And you can run third-party applications on your database hosts. So an example of this would be you can run SharePoint, for example, which installs services that run on the database host. Or you can run Microsoft Dynamics on that SQL Server host, and you're getting the operational benefits and management benefits of RDS, but you're also able to customize the RDS and the host it runs on. So this is just a slide to give you all the features at a glance. You can take a look at this. I haven't really covered all the features that are listed here, but this is just sort of an easy way to compare and contrast the different capabilities with these 3 different versions or deployment options for SQL Server. The last thing I want to say relates to modernization. So Andy will talk about this more, but we do offer 8 different databases that give you the ability to either run SQL Server on an open source platform, an open source product that provides a level of SQL Server compatibility, or if you as the database administrator or developer have been overloading the relational database model, and you've been doing things that are really better suited for a graph model, or you've been doing things that really are better suited for a cache in front of a database, or if you've been storing documents inside a database, there are lots of use cases for which we have purpose-built databases, and we encourage you to use the right tool for the right job. So we have a strategy where we say SQL Server is great. All of us have been using SQL Server for decades, and we all in Amazon love SQL Server, but at the same time, there are lots of databases as well that can optimize individual use cases. So let's jump into some of the details around migrating, deploying, and operating SQL Server at scale. The first question that people have concerns, how do I migrate SQL Server to Amazon? And we have these 2 deployment options, either EC2 or RDS. And so the first, and these, by the way, are just the 3 most popular deployment options. There actually are many, many more ways of moving SQL Server to AWS. The first and the easiest way is to use the database migration service. And this is a service that we provide in which you identify a source database and a target database. The source database will typically be on premises. The target database will typically be in a VPC on AWS. And by identifying the source and the target and setting up networking between the 2, our service will provide a copy, a full load copy, and a change data capture record by record change copy from your source database to the target on AWS. And so DMS is the easiest way where, by setting up a URL to point to source and target and turning on the service, it takes no additional effort to migrate a database to AWS. The databases are kept in sync. So using this CDC feature, even after the full load of the database on Amazon, whether it's RDS or EC2, we'll continue migrating deltas. We'll continue migrating CDC records in the database, which means that if you want to, you can have 2 systems running in parallel until you decide, oh, I can really trust that the database works, that the applications that talk to the database work, and do a full cutover onto AWS. So this is really the primary, and if I can be so bold, this is the recommended service for migrating SQL Server databases to AWS. If you have a really large database where you don't want to transmit data over the wire, we have an appliance called Amazon. Snowball Edge, I'm just blanked on that. Snowball Edge is an appliance that will ship to your facility, and you can copy just using SMB, you can copy 5, 10, 100 terabytes of your database to this appliance, send the database to Amazon, we'll load that appliance, and then we'll use this CDC load capability to load the deltas and keep your databases in sync. So if you have a really large database, you don't need to start with this idea that everything has to be transmitted over the wire. The second service that we have, which is a service for only migrating to SQL Server on EC2, is called the Application Migration Service. You might hear us talk about this as MGN. I think enough acronyms are already taken that MGN is the acronym for the Application Migration Service. And the Application Migration Service is a block copy service. And so what we'll do is, in some ways it's similar to the Database Migration Service, where you point to a source database or a source instance, a source virtual machine. It could be on VMware, it could be on bare metal, it could be on Hyper-V. You point to an EC2 instance on AWS, which you want to host your database, and then the MGN service, or Application Migration Service, will perform a block copy. And as blocks change on this source, we will continue migrating those blocks to the target. So although it isn't copying at a row level, it is copying at a block level, and you can also use MGN to keep two databases in sync. And then once you've done the level of testing that you need to do to accept that SQL Server is running properly, you can perform a cutover and cut over DNS and start using your new database. So the Application Migration Service is also a highly recommended service, especially if you're moving to EC2. Both of these services eliminate a lot of the scripting and the configuration required of setting up, for example, backup and restore. However, backup and restore is what most DBAs are familiar with, and they've been using it for years, and they've written their scripts. They've written scripts around it, and backup and restore, of course, works very well, whether it's a single .back file or multiple .back files. So we've got a third service called Migration Hub Orchestrator, which is an orchestration tool or a workflow tool, which is wrapped around, our service is wrapped around SQL Server backup and restore. So rather than you using your own scripts, you can use MHO, and we will essentially perform a backup of your database on premises or elsewhere. We will back it up to Amazon S3, and then we'll restore it to a SQL Server that we deploy on Amazon EC2 or Amazon RDS. And so this is a third option for customers who say, well, I'd prefer to use essentially a backup and restore function. So these are three options. There's many, many more ways of moving SQL servers to AWS, but these three are, I and Andy and Amazon SAs have been using these services for a long time. Okay, now when you actually want to deploy when you want to start using your SQL Server on AWS, you've got a couple options. So first we have a web option, the web console, just to manage either SQL Server on EC2, kicked off from an AMI, or managing RDS. In both cases, we have a web console for both. And a DBA would find these web consoles super easy to get used to. We also, for scripting purposes, we have the Amazon CLI command line interface and AWS tools for PowerShell. So anything and everything that you do on AWS, you can script. And to be honest, we would recommend scripting, ongoing tasks like running SQL agent jobs, performing out-of-band backups, and any kind of rebuilding indexes. We would actually recommend that you perform these kinds of ongoing maintenance using the CLI or using the AWS tools for PowerShell. We also have AWS software development kits for .NET developers, Python developers. We also have CloudFormation templates and the Cloud Development Kit if you want to just stamp out, if you want to define the SQL Server's configurations that you want and then just stamp them out using a JSON or YAML template. And the CDK does the same thing, but using, for example, C# code. We also finally have a launch wizard that operates on SQL Server on EC2. So many of the configuration options that we have for RDS, like setting up high availability, choosing the amount of compute you have, choosing the amount of storage you need, the capacity of storage, the type of storage, choosing the networking performance. You can walk through a step-by-step wizard, the AWS launch wizard, and we will give you a configuration according to the launch wizard on EC2. So we have all these options for basically getting started with SQL Server. And then you have the option of, okay, great, I've migrated my SQL Server, I've deployed SQL Server in the way I want to using one of the tools or just a migration. I've started SQL Server at the command line or in the AWS or RDS console. Now, how do I manage performance on AWS? And it's very similar to managing performance in any other SQL Server database. You have essentially 4 dials or levers. You can control CPU, RAM, networking throughput, and type of storage. And you can sort of dial any one of these, any or all of these individual resources up and down to match the best price performance that you need from your database. And I should just mention that when you select an EC2 instance or an RDS instance, you get all 4 resources defined for you. You get to pick what instance family am I using, what storage family am I using, and this will give you your baseline performance. By selecting your storage type, there's a lot of, basically, depending on your database, if your database is memory constrained, and most SQL Server databases in production use are more memory constrained than anything else, or either memory constrained or I/O constrained. But we would encourage you to use our memory optimized instances, both on the RDS managed SQL Server service and on EC2. At the same time, if you know that your database is I/O constrained, you can choose a storage type. You can choose provisioned IOPS, and you can choose the storage type you want and dial in the number of IOPS that you want to assign to your database. So these are essentially the main dials and levers for managing performance on SQL Server. And as you need to, you can scale all of these dimensions. I've listed here sort of the mins and the maximums of the resources that we make available to you. So I won't read the slide here, but you can see you have a very large range of resources that you have available to you and which you can select to optimize your SQL Server. So now, a lot of customers come into AWS and they say, okay, well, I understand SQL Server and I understand the general concepts of, yes, compute, storage, networking, all of that makes sense, but how do I actually get started? Like, what are the resources that Amazon has and recommends for SQL Server? And we divide the world into basically compute and storage. And so when it comes time to deploying a SQL Server instance, one thing that many customers do is they just match the hardware configurations that they're using on premises. That's an okay first step, but it's also good to know that we have the 4 different instance types that I've listed here, which will allow you to essentially choose which instance family you want to use depending on how you use your database. So if you have a dev and test database which isn't designed for production purposes, it'll be your lowest cost instance type and allow you to get started with up to 32 gigs of RAM in an instance and up to 8 vCPU. We have our T3 instance type, which works on both SQL on EC2 and SQL on RDS. And important to know is that our burstable and our general purpose instance classes have a 4-to-1 ratio of memory to compute, meaning 4 times as many gigabytes of RAM per vCPU. And so that tells you this is sort of a generally evenly balanced system, but it's not biased towards high memory or biased towards I/O. So just for getting started for test and dev, we encourage you to use the T3 family of instances, which span a wide range from that 32 gigs of RAM and 8 vCPU all the way down to 1 vCPU and 1 gig of RAM. We have the M5 and M6 families for general purpose computing, which also has a 4-to-1 memory to CPU ratio. And it's important to know that 4th column on EBS optimized, so storage I'll talk more about storage in just a second, but storage on AWS is network attached storage. To SQL Server, it'll feel like using the SQL Server drivers that come with Windows Server on AWS, network attached storage will feel like local disks. And so, but it is important to know that under the covers, it is network attached storage, which makes it important to know what is the EBS throughput to my storage if I know that I need to optimize I/O. And so this table here also lists the EBS optimized throughput of these different instance families. Some of our instance families, you'll notice on the far right, also support some level of instance storage. This is actual locally attached storage. And so if you want the highest possible performance, you would use locally attached storage as opposed to EBS network attached storage. Locally attached storage is ephemeral, meaning it'll go away if you reboot your instance. And so we recommend that you put tempdb on instance storage, where you can take advantage of locally attached NVMe high-performance SSDs for tempdb, but you can put your actual database tables on EBS. So anyway, so take a look at this table. For production databases, we typically recommend and see people using memory-optimized instances. And you'll notice that these are anywhere from 8:1 to 55:1 ratios of memory to CPU. So if you know that, a typical example like Amazon.com, if you know that when you read a customer record, it's likely the customer is going to update that record, the customer is going to select a credit card which is tied to that record. If you know that your database access pattern means that once there's been one access, there's likely to be additional accesses of the same rows in the database, then you probably want to use a memory-optimized family. SQL Server is very good using the buffer manager and the buffer pool in maintaining rows in RAM for recent disk accesses. And so the memory-optimized family is really the family for production databases. And storage optimized is similar. There's also an 8:1 ratio, and we give you a massive amount of storage in tempdb. If you really want to put databases directly on local storage and then manage high availability on your own from local storage on one node to local storage on another node. So we have 30 terabytes of NVMe high-performance SSD storage in the i4i family listed at the bottom. So those are sort of the inside baseball of Amazon EC2 and RDS and sort of an introduction to how would you choose instance types on AWS. It was relatively recently that we announced support for the M6i family and the R65 family. Okay, now if you want to change the performance of a SQL Server instance that's running, this is one of the benefits of AWS. It's easy to change the instance type. You issue a stop and a start or a reboot. You can, if you want to change your instance type, you can fail your production database over to the standby, update the instance type of the primary, and then fail back. You can use scripting to scale compute capacity of your workload so that you're using a smaller instance, for example, at night, if you have fewer users at night. You can, at any time you want to, you can change the storage type or capacity from general purpose storage to provisioned IOPS storage. You can do all these things with both EC2 and RDS. Your modifications to storage, both type and capacity, will take place in a few minutes of when you make the changes. And you make the changes through the same tools that I mentioned on the previous slide, the consoles or the CLI or PowerShell. Now, we also provide a set of CloudWatch metrics for SQL Server on both EC2 and RDS. And CloudWatch metrics, you can see all the different, this is actually a small subset of the metrics that we support, but you can use performance insights you can use application performance insights on EC2, which allows you to look at how SQL Server is performing both as an application, SQL Server as an application, and you can also look at the operating system statistics as well. So CloudWatch and application insights for SQL Server will give you access to everything here spanning the OS and SQL. And you have essentially the same metrics when you're running on our managed relational database service. And we have a similar service to application insights called performance insights on RDS, where you get the type of graph that you see on the right side. You can pick the metrics and then graph them, and you can also tie these to alarms and and perform remediative actions as needed. Okay, now I've talked about CPU, and I've talked about some of the storage options. Let's dive a little bit deeper into the storage options. So I've mentioned the different types of instances over on the left, and all of these use EBS. So all of these instance types will take advantage of EBS storage. And EBS storage is our standard elastic block storage, which is used for many high-performance workloads, including SQL Server. We also have another storage type that I haven't talked about so far called FSX. Amazon FSX for Windows and Amazon FSX for NetApp on Tap both provide SMB storage to any application, including SQL Server. And so Amazon FSX is a shared storage technology where you can have multiple nodes in a cluster, either a failover cluster instance or an always-on availability group, mounting the same shared database on shared storage using Amazon FSX. And then this gives you the ability to use things like failover cluster instances or always-on availability groups, both. So this technology is configurable. You can dial in the capacity, you can dial in the IOPS, and at any moment in time, you can change the characteristics of your FSX storage. I should mention that the maximum capacity for Amazon FSX is 64 terabytes, and the maximum throughput is 2 gigabytes per second. So those are the upper limits. And you're using the instance ENI to connect to Amazon FSX. Oh, I should mention this last bullet on the right is a very interesting bullet. So in some cases, customers have picked a very large compute instance from one of those families on the previous slide. And the reason they have is because as you get a larger compute instance, you also get greater EBS throughput. And so some customers, they don't actually need greater compute, but they do need greater EBS or storage throughput. And so they've been sort of artificially forced, if they're only using EBS, to pick a higher level of compute than they actually need for their database. FSX will solve that problem, because with FSX, you can choose any level of compute you need. Maybe you have very little compute required in your database. You don't have a lot of stored procedures or custom functions, but you do require very high I/O. And so Amazon FSX lets you tune the I/O to whatever you need without being forced to have a commensurately large EC2 instance. Okay, and just to provide a summary of the different types of EBS volume types and performance, you can see in the slide here that we support GP2, GP3, and IO1 for both EC2 and RDS. GP3 came out just about a week ago, so this is a new capability. In general, with Amazon, both instances and storage types, you want to pick the latest generation because you'll typically get the same or better performance at the same or lower cost. And so it's silly usually to use older storage types and older instance types. And you can see on the slide here what the performances are for these different types of storage, from the most basic level on top to the highest performance on the bottom. Okay, and finally I want to just end with a case study. I really like this case study. This is the Angry Birds case study, and Rovio runs their Angry games for mobile applications and for browsers on Amazon RDS for SQL Server. And we asked them, why have you decided to do this? And they said, well, first of all, you give us all the scalability we need. One of the data points on the slide, it may be a little bit hard to read. One of the data points on the bottom slide is that at nighttime, between certain hours, depending on the time zone, Rovio will experience 120,000 new users per hour onboarding onto Angry Birds, and RDS for SQL Server has no issue handling that. So the Rovio team out of Finland said, well, we get the scalability, we really like that. We also have to be very attuned to what's happening in the database and what the user experience is. And so we don't want to have to be worried about operations management, backup, and patching. And so they really have said, this gives us a production database that will meet our scalability and management needs without our having to devote scarce scarce developer resources to those tasks. And at the very bottom, there's a quote by Nicola Peltola who says, with AWS, we have fewer security concerns. We don't have to worry about data center access controls on a physical server, for example. So there you have it. That's the quick overview of SQL Server on AWS. What are your deployment options? What are your compute options? What are your storage options? And then how do you get started with the console or scripting? And with that, I will let Andy dive deeper into the next topic.
So yeah, who's that weird bald guy who's been lurking behind Bill? So hi everybody, my name's Andy Hopper. I'm also like Bill, I'm a principal solutions architect. So Bill's been talking a lot about how to migrate and operate SQL Server on AWS, but let's talk a little bit about how you keep it running on AWS, because after all, that's what your customers are gonna need for their dial tone. And by the way, first I'm going to point something out here. You'll notice the acronym RDS on here. I'm not going to be talking about EC2 in the next few slides. Why? Well, all the stuff that you already know about migrating, operating, doing DR, HA with SQL Server, those all still apply with EC2. So there's really nothing new there. What we're going to be talking about here are just what's going to be different if you do choose to re-platform and run your databases on RDS. So out of the box, RDS provides automated backups for your databases. This actually is an option when you go to like the launch wizard inside RDS. It's going to have automated backups enabled. It's optional. You can certainly disable it if you choose. Obviously, we don't recommend that you do that, but you do have control over that. Now, one thing I want to point out is that when it makes a backup, it's actually making a volume shadow copy of the volumes that your database instance are running on. What that means is it's backing up all of the databases that are running on that RDS instance, and because it's using VSS, it's actually going to be an application consistent snapshot. So if you had to restore, you're not going to somehow restore blocks that are like mid-transaction, that sort of thing. Now, one thing to really point out is that with these automated backups, there's a retention window. So by default, we will retain those backups for 7 days or a week. After a backup is older than 7 days, we'll automatically delete it. You have the ability to ratchet that all the way up to 35 days if you so choose, but that's the maximum. After 35 days, then those backups are going to get deleted. And incidentally, you can also set a backup window. So if there's a good time of day that you know you're going to have low activity on your database, or you just know this is going to be a good time to make a backup, you've got the ability to control that. Now, a lot of customers ask, okay, well, wait a minute, 35 days is the maximum? What do I do if I want to retain a database for longer? Well, we're in luck. We have manual snapshots. So functionally speaking, these are identical to the automated backups that we make. They're using the same technology. They're doing a volume copy of the database, of all the databases that are on that RDS instance. But you've got the ability, number one, to control when they get taken. So if you want to do something outside of a backup window, maybe you're preparing for like a big upgrade or something like that, you can take a snapshot at that point in time. And also, you get to control the lifetime of those snapshots. You can retain them as long as you like, but be aware, it's on you to decide when you don't want them anymore. So if you take a manual snapshot, we'll keep it as long as you want, and it's on you to know when it's time to go ahead and delete those. Incidentally, with the manual snapshots, you also have the ability to copy those into other regions. We're going to talk a little bit more about DR in a few more minutes with like read replicas and whatnot. But you do have the ability to actually share those snapshots or copy them into other regions. Now, what if you don't want to copy all the databases that are on a particular RDS instance? What if you want to take a single database or want to restore a single database? Well, we're in luck. RDS supports the ability, SQL Server's native ability to do backup. So if you have a .back or .dat file, all you'll do is you'll copy that into Simple Storage Service or S3, and then you can enable a feature in RDS to support S3 native backup and restore, and then you can restore those databases into your RDS instance. We also support the ability for you to do multi-file backup. So if you've got like a really large database and you want to accelerate the process of making a backup or restoring from that backup, you simply copy multiple files into S3. You have a naming convention so that you can wildcard it, and then you just tell RDS to restore, and it'll just start restoring the database from all of those files. One thing I do want to point out is while we support the ability to restore transaction logs, RDS does not support the ability to make a backup of a transaction log. So if you need to do a point-in-time restore, RDS natively supports the ability for you to go to some arbitrary point in time and say, okay, I'd like to restore this thing as of Wednesday, last Wednesday at 8 p.m. It will simply restore a new instance key, a new instance of your RDS instance from that point of time snapshot. Let's see, anything else on there? Nope, okay. Oh yeah. One thing you might notice that's marked as new, we now support compression as well as total database encryption, or TDE, for your databases as well. Now, that's all well and good. We've talked about how you can back up your databases, but what if you have other application infrastructure? Maybe you've got servers that are running websites. Maybe you've got a file system, managed file system like Windows FSX. Maybe you're running SAP HANA. We just literally announced support for SAP HANA with AWS Backup this morning. What AWS Backup will do is coordinate the backup of other AWS infrastructure, S3 buckets, Elastic Block Store volumes, what have you, as well as your RDS instance. So if you wanted to have a way to restore all of your application infrastructure as of a given point in time, you just set up a backup procedure with AWS Backup, you tell it when you want to do it, and when you're finally ready to restore all of that infrastructure, you simply choose a restoration point ID, and then you can go ahead and restore everything to protected resources, and you're ready to start moving that into production. Incidentally, AWS Backup also natively supports the ability to copy all the backups that it makes to other regions if you wanted to have a kind of a regional disaster recovery support. Now, let's talk a little bit about high availability and fault tolerance. So Bill mentioned earlier, RDS supports the ability for you to actually have multi-AZ or multiple availability zone support. Now, the way this is done in practice is you'll go into the console. You'll notice if you go through the little launch wizard we have for RDS, you've got the option to do like a dev test database or a production database. And you'll notice for production database, we recommend that you choose multi-AZ. What this will do is it'll set up 2 instances of your database, or database server that is. There'll be a primary, and it's got to have a listener endpoint that points to it. That's what you configure in your web.config or your connection strings or whatnot for the app to talk to the underlying SQL Server database. And then concurrently, it's going to be operating a secondary node. That's going to be another instance, and what we're doing is synchronously taking all the transactions that are happening on that primary and copying them over to the secondary, so that it's always going to be up to date. A transaction will not return unless it's already been propagated to that secondary instance. So let's say you've configured everything up, you've got multi-AZ configured, and then something happens. A sunspot, a disk goes bad, CPUs go on the fritz, everything fails all the time. That's something our CTO, Werner Vogel, says a lot, because it's true. I personally have been subject to power failures, backhoes, all these sorts of things, and so you need to have a way to be able to sustain those. So what will happen is when RDS notices that the primary instance is no longer available, it will automatically move that listener endpoint over to that secondary node. So that's great. Your application continues to function. Your users will largely be completely unaware of the fact that infrastructure failed. However, if you look at this, we're no longer in a fault-tolerant configuration. I now have a single instance, and that's no bueno. We want to make sure that we're able to have that fault tolerance. Well, we're in luck. After that secondary node gets promoted and we get the listener endpoint moved over to it, RDS will automatically start provisioning a new secondary instance. And that secondary instance will be in the availability zone where the primary once was. What it will then do is start restoring that instance from a snapshot, and then after it's finished restoring it, it'll then sync it up with that primary node, and then it proceeds to operate just like it did before. It's just which availability zone we started operating in is going to be different because it failed over. Now, one thing I do want to point out is when you are operating in multiple availability zones, there is a data transfer charge. It's a small one, but it's there. So if you have a lot of application infrastructure that you launched into the original availability zone where your primary node was, it's going to be in your best interest to eventually switch that back over to being the primary. And so all you do is, you come in, say 11 o'clock in the morning when you're ready to start this thing, schedule when you actually want to do this, have a maintenance window, and then you just do a reboot and failover. And then the primary will the new secondary will then become the primary just like it was in that original AZ. Now, a lot of customers ask, well, hang on, Microsoft already supports the multiple node kind of approach using always-on availability groups. Well, as Bill mentioned earlier, RDS natively supports always-on availability groups. It depends on which edition of SQL Server you choose when you're launching your RDS instance. So it's going to be SQL Server, 2016 and up? Yeah, so we've got, 2016 version 13.52160 and higher. And what we'll do is similar to that original slide I was showing you with two database instances and two availability zones. We'll set up two instances, but then in a third availability zone, we'll set on an AOAG listener that's paying attention to the health of those nodes. But again, just like with that multi-AZ configuration I was showing you earlier, if it detects that there's a failure on that primary node, it will simply switch everything over to that new secondary, and then that provisioning process, just as I described before, will go through. Now, a lot of customers also ask, okay, well, this is great, you're talking about fault tolerance, but sometimes I have a very read-heavy workload. And so I want to have a way to spread the read activity, and I don't want to have everything going into my operational database. Well, RDS supports read replicas. Again, this is for SQL Server Enterprise 2016 and up versions, so it has to be the enterprise SKU. But what we'll do is we'll leverage always-on availability groups, and we'll actually provision a read replica. Now, unlike the multi-AZ configuration where I will synchronously replicate transactions to that secondary node for fault tolerance, with the read replica, it's going to be asynchronous replication. It's going to be near real time. I'm just saying that you can't guarantee it's going to be exactly the same as what you had in your configuration. But you're leveraging multi-AZ to ensure you've got uptime. You're just making sure that read replica has a copy of that data. Now, when you do provision a read replica, something very important, you'll actually provision a listener endpoint for that read replica. This will be different from the operational one. So you'll get, when you provision your multi-AZ group, if you're using SQL Enterprise, we'll set up an AOAG group. That'll have a read-write listener endpoint. But for your read endpoint, if you set up a new read replica, that will have its own dedicated listener endpoint. So that means that your application will have to be written in such a way where you can support multiple connection strings, one for read-write, one for the read-only path. Incidentally, like you see on the slide, we support up to 5 read replicas inside a region. And also, a read replica can be turned into a read-write node, but it will not participate in the original AOAG. So if you take a read replica, then promote it to be a read-write node, it will basically become a new primary. You can then proceed to turn that into a multi-AZ if that's what you want, but just be aware that you won't be able to have multiple read-write nodes inside that same AOAG group. Now, this is in practice what it looks like. Right? So it looks a lot like that multi-AZ configuration I was showing you earlier. You'll have your primary and secondary availability zones that have your instances set up. And then when you set up your read replica, you have the ability to control where that's going to live. And what's actually happening is under the covers is, as soon as the transaction gets committed to that multi-AZ configuration, we'll then propagate the changes over into that read replica. And again, I just really want to make sure I underscore the fact that it is a separate listener endpoint, so just make sure that your applications are configured to have, like a read path as well as a write path. All right, so this is a brand new feature, so I wanted to make sure I called this one out. I had a lot of customers who ask, okay, well, this is great, you've got read replicas, but maybe I've got a global application. Maybe I've got application servers that I'm running in Singapore, or maybe I've got something that's just running on the opposite coast, and so I want to provide low latency read paths for my application for my customers. Well, we just, literally 2 weeks ago, announced the availability of cross-region read replicas. And what you do is just like before when you're setting up a single region read replica, you simply configure what region you want that read replica to reside in, and then we'll proceed to do that asynchronous replication of all the transactions over to that node. This also happens to be a really cool way to be able to support low latency or low RTO recovery from a major disaster. If for some reason you need to evacuate your infrastructure from a region, you can then promote that read replica that you have in an alternate region and combine that with a service like AWS Backup and be up and running a lot faster, and also know that you've got the latest copy of your data available in whatever new region that you begin to operate in. All right, so this is all well and good. The last thing I just want to talk about today is Babelfish. This is a super exciting service. Frankly, I'm not going to be able to do it justice in the few minutes that I've got remaining. We do have a session that covers Babelfish in detail, and I'm going to give you the slide that's got the session IDs in there in a little bit. So like Bill mentioned earlier, we've got a lot of options for database developers or application developers who want to use purpose-built databases that are highly tuned to a given workload. However, not everybody's ready to throw a giant switch and move their application completely over to MySQL or Postgres before they have everything up and running. And so that's one of the reasons that we came up with Babelfish. So what this looks like in practice is it is an extension to Postgres. So if you're running on Aurora Postgres, there will be an option when you're launching it to enable Babelfish functionality on that. And what that's going to do is configure this extension. And here's the really cool part. It understands SQL Server's native tabular data stream, or TDS protocol. What this means for your applications is, in a lot of cases, you only have to change a connection string. Your application will continue to function. Your ADO.NET, your ODBC code, your ORM like Entity Framework or Dapper or something like that, it'll continue to function. Which is really cool because now all of a sudden you're running on a Postgres database. You no longer have to pay for a SQL Server Enterprise whatever license. And also you stop having to worry about SQL Server end of support. I don't know how many people here are running on SQL Server 2012. It's surprising how many people I encounter who are still running that engine just because it works. But Microsoft, just like this summer, announced end of support for that version of SQL Server. When you run on Babelfish on Aurora, you're no longer having to force yourself to buy a new version of SQL Server in order to get technical support. Now, I'm not going to read every single point on this slide, but people ask often, what does Babelfish support? Well, it supports all the mainline use cases for SQL Server. I will point out there are going to be edge cases, things that are native SQL Server functionality, service broker queues, XP command shell, that sort of stuff. The good news is that we've actually got a website, babelfishpg.org, that you can go to, and it's got a full documentation of the things that we don't currently support with Babelfish that SQL Server currently does. The good news is that we're continuing to rev Babelfish. We keep adding new features as time goes on, so it may very well be something that's not compatible today will be compatible shortly. So in order to know for sure that your application is going to be compatible, though, we do have a ways for you to assess the compatibility of your application. So we've got option 1. This is the Babelfish Compass tool. This is actually produced by the Babelfish team. And what we'll do is I'm going to go ahead and just build this thing all the way out. There. So what we'll do is with every release of Babelfish, point release, major release, we'll actually produce a new version of the Babelfish Compass tool. Now this is a command line tool that you run. You hand it whatever script you want it to analyze, and then it'll spit out an assessment with results with red highlights showing you anything that's not currently compatible. If you do find something that's incompatible and you do want to move to Babelfish, there may be an engineering effort. If you are using something like service broker queues, it'll be time to move to another queuing service like SQS, for example, or Kinesis or something like that, depending on your workload. In the happy case, where you find that there are no incompatibilities, you then just can go ahead and import your DDL. And we'll talk about what that looks like in just a second. Now, with the Babelfish Compass tool, you do need to export your DDL or your queries in order for the Compass tool to be able to analyze them. However, some customers just want to be able to point to some tool at their database in situ. Well, this is where the schema conversion tool, or SCT, comes in. Nominally, this tool is used to be able to convert schemas like from, say, SQL Server to MySQL, for example, or to Postgres. But what it can also do is automatically perform that Babelfish conversion analysis for you without you having to dump the database definition language for it. I do want to point out that while Babelfish Compass is released with the same cadence as Babelfish itself, the SCT analysis is going to be at SCT's cadence. So there's a chance that there's like a small window of time where SCT's capabilities may lag slightly behind Compass just because I haven't done a new rev of SCT yet. So the best case is use Babelfish Compass. The easiest thing to do is use SCT. In all likelihood, it's probably going to hit all the things that you're probably likely to be encountering in the first place. So when you do want to go ahead and migrate everything over to Babelfish, the very first thing you're going to do is export the data definition language for your databases. You're going to point that at the listener endpoint for Babelfish. By the way, since it's a TDS endpoint, the default port is 1433, just like SQL Server. You'll then run the T-SQL commands. You could even use SSMS Query Analyzer to connect to that Babelfish endpoint and just run this script as if you were talking to a SQL Server database. It'll create all the structures. It'll map them to corresponding PostgreSQL database structures under the covers. Incidentally, and I neglected to mention this earlier, Babelfish supports both the SQL Server endpoint as well as the Postgres endpoint. So if you wanted to gradually move yourself over to Postgres, you have the option to just change like one aspect of your code at a time over to Postgres, as opposed to having to change all of your database access code all at once just because you're moving to that new database engine. Again, once you get your DDL, you'll run whatever assessment tool you're going to use to test it to make sure it's going to be compatible. If you do find something that's incompatible, there may be an engineering exercise to be done, but then you'll import that into Babelfish, and then you can use a tool like the database migration service to get that all the data into Babelfish. All right, so we're approaching the end here. If there's anything we want you to be able to walk away from this session with is just these key takeaways. First and foremost, AWS gives you lots of ways to run SQL Server in AWS. You've got a whole bunch of services that can help you. You've got people like me and Bill, who will help advise you and guide you down that process and help you choose what the best modernization options are. In addition, when you are ready to start your modernization journey, that's where Babelfish comes in. That's a great way for people to start moving to open source technologies, drop really expensive licenses, get themselves freed of Microsoft's end of support terms, and really start modernizing their database applications. And last slide. Okay, so I'm going to pause here for a minute if anybody wants to take a picture of these sessions, but these are just a few that we think are going to be of interest to you if you're already here in this session. You'll notice one of them is a deep dive into Babelfish. I do highly recommend that you go to that one. We have the advantage of being pretty early in the week, so all these are going to be presented after us, so hopefully you'll have a chance to get to modify your schedule if you are particularly interested in any one of these. And this brings us to the end of our session. Thank you all so much for coming and joining us today. We hope this was useful to you. If you have a chance, please use the feedback tool in the event app. I promise you we use that feedback to help improve these sessions, and it would be greatly appreciated. Again, thank you all for coming, and I hope you enjoy the rest of your reInvent.